Okay, hi everyone. Thank you for joining this webinar today and seeing the presentation from the British Dam Society. So just to introduce ourselves, my name is Rachel Avery. I am the current British Dam Society Young Professionals Chair, and I'm joined by Henry Foster-Roberts, who is our Young Professionals Committee Events Champion. We also have Sam Tudor from the BDS as well, who will be presenting for us today. And then we also have Matteo as well, who is the ICOLD Young Professionals Forum Chair. So what we will do during this session, Sam will present for us, and then we'll have a question and answer session, followed by a short presentation from Matteo. So just before we get started, just a couple of things. If everyone could please leave their cameras off and themselves on mute as well during the presentation, as this is being recorded as well, that would be great. If you have any questions, please put them into the chat and we will read them out afterwards. Okay, and with that, I will hand you over to Sam.
Lovely, thanks Rachel. I will just share my screen now. Okay, good afternoon, everybody. I'm Sam Tudor. I'm Dam Safety Engineering Manager. I work for Dorcombe Welsh Water. Just a little bit of context around that. Welsh Water is a water utilities company. We manage a portfolio of around about 130 reservoirs. Lower Lliedi is one of those. And we supply potable water and sewerage to around 3 million people. So in terms of this presentation, the content really is I'll cover some of the key dam details, identify the potential issue or the identification of it in the spillway. We'll also look at the escalation of the incident and the immediate actions that were taken, remedial works in the first spill event afterwards, and finally a few lessons learned. So in terms of the key dam details then, Swiss Valley Reservoir it's Swiss Valley in Llanelli in Wales. For the international context, that's probably not particularly useful. So I have dropped a pin there and a map of the UK that shows approximately where it is. So the dam, in terms of international scale, probably isn't that huge. It's 21 metres high, 120 metres long, and holds somewhere in the region of 700,000 cubic metres of water. So it does come under the ICOLD remit of a large dam being over 15 metres high. Surface area is quite small at just over a square kilometre, and it's a traditional Pennine style earth embankment dam with a clay core. It's quite a slender clay core with just selected fill. It's not zoned or anything like that, being constructed in 1878. And in profile, the dam does turn upstream towards its hydraulic right-hand end, which you'll see in a site schematic later. It doesn't supply a water treatment works for onward potable water supply, but it does act as a backup supply to a steel work, so it is important for industry. There isn't a requirement to give environmental compensation releases into the river, though we do naturally do that, and to be honest, the reservoir's on overflow for sort of 11 to 12 months of the year, so it's not often that it's not flowing. We don't regulate the river for downstream abstraction, and in terms of our portfolio risk assessment, it does lie in the unacceptable zone, with around about 1,000 lives at risk downstream. So just zooming in a little bit, just to give some context, the red circle on the left-hand satellite view is of the dam. So it is a cascade dam. There is another dam immediately upstream of this one, which is the Upper Lliedi Reservoir. And then you can see quite clearly that there is a town just immediately downstream, effectively starting at the toe of the dam. In terms of the site general arrangement then, access is taken from the right-hand side of this picture, and then we initially cross over the overflow via the bridge. It's a stepped masonry spillway chute with a slight curve in it. The dam does have a midway berm from construction, and you can see here where it does turn upstream at the hydraulic right-hand end. There's no real details on this, but it was likely to do with the geology during construction. Underneath the spillway, there is the draw-off tunnel, and that does cross the spillway about 2/3 of the way along. Historically, we have had issues with the spillway with the sort of internal wall here, and also the floor collapsed underneath it, so that there has been works in and above this sort of area that the tunnel crosses the spillway, being a natural weak area. And you might see just off to the hydraulic left here is the original clay borrow pit for the dam as well. So it was really locally imported. In terms of spillway, going back even sort of 9 months before this happened, the spillway was performing well. It had the typical issues we'd have with a masonry spillway, just keeping on top of the mortar joints, but in general, there was no causes for concern. This photo was a rare dry point for this reservoir. I say dry, you'll see puddles, but where I am in Wales, this is classed as dry. So what it shows is roughly the area that my laser pointer is, that hopefully everybody can see. There's the line where we go from a more traditional dressed masonry stone with grout joints into this area of placed stone that's more just to break up the flow and dissipate some of the energy between the end of the formal spillway and the river channel. And that's important because that was the area that the failure occurred. So identification of the issue in the spillway. So just a bit of context. Prior to the incident, we had a number of named storms in the UK, and essentially these meant that the spillway was on high periods of overflow for weeks at a time. And within Welsh Water, we have an internal trigger level document, which says for this site, at any point that we're 0.8 meters or above on overflow, we move to a daily inspection, just with the increased risk of those high flows down a masonry channel. During Storm Henk, which peaked on the 2nd of January, just after New Year, we had reservoir levels of 1.227 meters above top water level. For a little bit of context, the 1 in 10,000 year event would have put this about 2 meters on spill. So we were well below sort of the design and the PMF standards for this site, which the spillway is physically large enough to pass, but the sort of ability for it actually to do it is potentially a slightly different question. Incident was identified by one of our dam inspectors, so they attend site. At this point, they were attending site daily to do the surveillance until the water levels reduced fast enough or far enough that we could then sort of make sure that the spillway condition was good. And their job really is to identify and escalate the issues. Following them identifying the issue, I attended site. I think it shows our internal procedure works really well, that from the dam inspector identifying the issue that I'll show you on site to us starting a precautionary drawdown was less than 90 minutes. So this is pretty much what the reservoir looks like during the winter when we're getting storms. There's an awful lot of silt upstream. It does pretty much turn the water to chocolate, which doesn't really aid the identification of the issue downstream when we had it, because obviously the water coming down the spillway from the start is extremely turbid. So on the day that the dam safety inspector arrived on site, he sent me these 2 images. And he was just a little bit uncertain to exactly what was going on within the spillway at that time, but he knew something wasn't right. So as you can see in the left-hand photo, there's a couple of rocks just sticking out of the flow, but as you can see on the hydraulic left as well, there is a natural rock outcrop. So when we're initially looking at the photos, it was a bit of a strange one where you're sort of trying to determine, has the rockfall come from the natural ground or has it come from the spillway? So as you can see in the right hand photo, there is quite an area here where we can see that rocks have come away in the past, and there is a natural crack system in the rock there as well. So there was the initial sort of thing in my head of it's possibly just that, but let's go to site and make sure. We also have in the left-hand photo, you can see where the water does become quite turbid at this point. Now, this is the point that we go from the masonry channel into the placed stone. But as you've seen from the earlier photo, that's pretty much what the reservoir water looked like at this point as well. So trying to determine whether that's being caused by ongoing erosion or it's just turbid water does become quite difficult. Less visually obvious from the photos, you can sort of see that there is an area here where the water did become more turbulent again, which made me think that something could be going on in that area. So with us sort of knowing, going back through photos, seeing moss and lichen on this area, no other clear sign of rockfall, turbidity, colour in the water, decision was made that we had enough evidence at that point to start a precautionary drawdown of the site, take the reservoir off spill, and just make sure that the spillway was okay. So as we look at the escalation, just a little bit of a timeline. Let's face it, we're engineers, we all love a bit of a Gantt chart. And it really just shows that this first sort of section from the issue being observed a little after 11 o'clock in the morning to where we were at 5 o'clock in the afternoon, where it'd been escalated up through our management system to managing director level. We'd started implementing our emergency planning process. Our regulator had been advised initially that we had an incident at the reservoir. And also we'd started to mobilise our capital engineering departments and contractors to start coming to site. So we had a couple of things that we had to take as immediate actions. First off is we wanted to commence a precautionary drawdown. So in the UK, we class a precautionary drawdown as when we don't feel that the dam's in immediate risk of failure, but we need to get the water out of it quickly. And for that, we aim at around about 300 millimetres a day of drawdown, which is less than the full capacity. And that just makes sure that although we're managing the risk, we're not then putting a greater likelihood of having things like slips on the upstream face. We escalated it within the business and got an incident command structure in place. As I said, we escalated it to Natural Resources Wales, which is NRW, which is our enforcement authority and our regulator. We mobilised the contractors to site, and we also had to notify local councils and restrict public access. This dam is a site that is there for high amenity value as well. We have fishing on the site, kayaking, other water sports, and also the path that runs around the reservoir is a very popular public footpath, which we had to close. So as with any incident, you always get asked some really difficult questions and everyone wants to know the answer to, and the answers aren't always obvious and easy. So the first one is, how long will it take to draw it down? How long will it take to get that water out and reduce the risk? How long will it take to refill? So immediately after you've been asked how long it's going to take to get the water out, somebody wants you to decide how long it's going to take to get the water back into it again if we have subsequent storms, which, you know, as we all know, it depends on the size of the storm. And finally, the most difficult question sometimes to answer is, will the dam fail? You know, at this point, we didn't have all the information. But these are the kind of things that you're likely to be asked in these kind of situations. So this photo is taken around about 24 hours after we'd started doing our precautionary drawdown. As you can see, we'd significantly reduced the amount of overflow. And we could clearly see that there was damage occurring. So this is around about 0.12 meters above overflow. There was clearly a scour hole that had developed at the end of the spillway. For anyone who's particularly eagle-eyed, you will see a little bit of sort of flattened grass in this kind of area. We do know we get a bit of wave slop coming out of the spillway as well in high flows, but it's not considered an issue because we've got like a grasscrete liner under this area to manage that. So this is almost that point where you get not a sense of relief, but you're happy that you made the right decision to sort of go into this incident phase where, you know, the justification that something was occurring has happened, and now we're in the point where we've got to try and do something about it. So we continued trying to get water out of the reservoir. One, so we could fully understand the amount of damage that had occurred, and also we needed to draw the reservoir down to have that safe flood margin whilst we undertook works to fix it. So as you can see, this is pretty much the exact point that the formal masonry of the spillway finished, and we've moved on to the placed stone. As I say, there is a crack system here, and the right-hand spillway wall extends beyond the toe, but I suppose at the point when it was constructed, they looked at this natural rock outcrop and sort of assumed that that would be a perfectly suitable bedrock to pass the flows on that wall. And what we believe has happened is, with the high periods of rainfall, high groundwater, water's gone through the crack system in the rocks, and we've developed enough pressure underneath to start uplifting some of these placed stones. And obviously, once that sort of turbulent flow starts and they've been lifted, then it just sort of unravels. And that stone pitching pretty much extends to about this point here, and 2/3 of it were either removed or down the river. So yeah, it made quite a mess really in what was probably 2 days between the start of the incident and sort of the point where we had no water flowing down it. The spillway channel is probably around about 5 meters wide at this point, and the scour hole that was created was about 5 meters square, and we think around about 2 meters deep. One of the key concerns that we had is that it had started to undermine the right-hand side wall of the spillway. So on the other side of this wall is the toe of the dam. Clearly, if this had continued without the damage being noted, then we would have had the potential for this wall to collapse, the toe of the dam to be eroded away, and a potential dam failure mechanism there. Moving on to the remedial works. First priority really was gaining safe access. So you can see in the winter period, we had a few trees fall down. There was quite a large tree at the top of this rock outcrop, which had to come down because it was overhanging quite badly, and we couldn't really put people down there working until that had come out. And we had to build an access ramp down into that sort of spillway really to be able to get plant and people down there safely. The only one good thing that you can probably see in the background is, for the first time in about 6 weeks, we had blue sky, and we pretty fortunately had that largely throughout the 2 weeks it took us to fix this. But what that did mean is it was cold. Average sort of daytime temperatures were around about -2 Celsius at that point. So yeah, not particularly great conditions to be working in, and certainly not great conditions to be pouring concrete. But we had an issue with the dam that we had to fix, and waiting for better, warmer weather wasn't really an option. So we had to design a solution as well. We had to prepare the area for concrete, cast a new slab, and demobilise in the middle of January before the next storm arrived. So the first job that we did after, as we were sort of removing the rubble, decision was made that we'd add pressure relief into this area, with that being one of the sort of initial failure mechanisms that we'd considered. And we had quite a good idea to do this bit rough and ready on site using a scaffolding system. And essentially we placed scaffolding on a grid. The tubes, although they don't all look like it on this photo, are sort of vertical and pointing very slightly downstream as well, so that we could cast the concrete in this and then just cut them flush, which was a system that worked really well, and something that I would certainly look at doing again if I was in a similar sort of situation, which hopefully I won't be anytime soon. And what was decided was we'd try and place as much of the stone back in as we could, and then grout that stone up, just to really make it faster to sort of reconstruct the spillway ahead of any new storms arriving in, which, although there wasn't any on the radar at that point, yeah, with this kind of area this time of year, you know you're never going to get more than 2 or 3 weeks before you get significant rainfall. So this grouting basically just sort of gave a little bit of structure between the bedrock that was there and the underside of the new slab that we were going to cast. So by this point, we've moved the stone back in, and we've filled it in with various size bits of stone as we needed to get a nice sort of fairly flat area. You can see that the grid has now been taken out of the pressure relief wells on the left-hand photo, and we've pretty much grouted it, and we're just sort of preparing at this point really for the new slab. You will see what we have installed or are installing at this point in this far end is a new terminal downstand, so that will act as the new cutoff of this section, just because we're losing this sort of stone area that would have sort of reduced the velocities of the flow before hitting the channel. It's just to try and prevent any sort of backwards erosion occurring at that point. And you can see on the right hand photo, we started pouring from the downstream end. It was a very simple design. Essentially, it was a couple of dowels were put in, or dowels were placed at various centres. I think it was around about 5 metre grid, and then a mesh laid on top of that, and it was around about 150 millimeters thick, the final slab, which extended from the downstand to the bottom step, just to cover this interface area as well. To do that, we decided, again, looking at the weather, looking at the likelihood of more storms arriving, we moved to 24-hour working. Although we couldn't pour concrete 24 hours a day, it just meant that we had a night shift that could come in, prepare us for the next day's work, and really keep things moving along. We had initially, it was only about 38 cubic meters of concrete, I think, in the end, for the slab. We had initially hoped to do it in one go, but with breakdowns on the concrete pump, we did end up having to do it in 2 separate pours. Finally, we grouted up the wall. So although we'd come back up above the erosion point, it was very difficult to tell exactly how undermined we'd had. So we ran a series of 3 grout pots at 300 millimeters above the slab and 1 meter above the slab. And then we poured a grout into those. The lower ones accepted the grout, and the upper ones pretty much accepted nothing. So we were happy to, at that point, that we were above the erosion that we had under that wall to protect that. And then round about a week after we finished the works, we came back on overflow, and it was working really well. Yeah, exactly as we'd hoped, really. And the concrete, we'd done the cube test, it had all come up to the strengths that we were after. So a good outcome. And as I said, this new slab actually extends all the way to the bottom of this bottom step, just to have that overlap and protect the joint that we've seen in this area, which was the start of the erosion. Obviously, as well, as I said, we had freezing temperatures, so we had to protect the new concrete while it was curing, and that's some thermal matting that we put over it. And the finish ended up being pretty good. I mean, it was just a brush finish for us to be able to walk on it as well. So it was nothing too fancy in that respect. But for a timeline from finding the incident to us having completed all the concrete and works and reinstated the river channel, and got all the kit back out of there, it was just over 2 weeks. I think it was about 15 days. And yeah, before the next storms arrived. So this is roughly the timeline. So yeah, 7-day curing period started on the 16th. So yeah, as you can see, 11 days of physical works, and then a couple of days afterwards of just reinstatement and things like that. So I think, in terms of having to get in there, set up pumps, come up with a solution and implement that, it was a testament really to a huge team effort from both people internally into Welsh Water, our contract partners, and also our external engineers as well. In terms of lessons learned, there was a few. Some of these might seem fairly obvious, but as the lessons learned, they were obviously not quite obvious enough. On-site pumping plans. So whenever you're doing these, please consider how big of a pump you can actually get to site, not just the fact that, oh, this pump's going to be big enough. Our on-site plan at the time had us to bring in 10 to 12 inch size pumps. Realistically, an 8-inch pump on a trailer was the biggest we could get there. Anything bigger than that wouldn't have got over the bridges, it wouldn't have got under overhead power lines. So yeah, really sort of think about not just what's going to get the water out, but what can you physically get there and set up reasonably quickly as well. Pump types, consideration for that is, if you've got a suction type pump, then you've got the same issue that you'd have with a siphon, where you get approximately 7 meters from the crown and it can no longer pull that depth of water. So somewhere like Lower Lliedi, where you might have seen from the photos, has quite a high amount of freeboard and then a wave wall to get over. We do lose quite a lot of pump capacity there. So if you do need to go beyond that, then submersible pumps are obviously your best way forward, especially on pontoons that can just rise and fall with the water levels. Concrete pumps and aggregate sizing. We couldn't get massive concrete pumps to this site. Again, we had the same issues as the pump or the water pumps. So because of that, aggregate that was 20 millimeters with the length of pipe that we were pumping was just clogging up the pumps. So we had to try and find somewhere with smaller aggregate, which at short notice was surprisingly difficult in this area. Though we did manage to get some 10 millimeters aggregate, but we did lose a day of concrete in with that issue. So we now include within our emergency flood plans where we can get any local suppliers of concrete with aggregates of 5 and 10 millimeter, just so that we know that they are available locally. And finally, probably seems like an easy one, but knowing how much water is actually in your reservoir can be really quite useful, especially when somebody's asking you questions like how quickly are you going to draw it down, how quickly can it come back up, and we had various different bits of data that showed it was anywhere between 700,000 cubic meters and just over 1 million, which is quite a significant difference in volume. So yeah, obviously that impacts all our rates. From a little bit of feeling when I was doing it, I'd say the actual answer to that, ironically, is probably somewhere between the two. So yeah, doing this drawdown, we had to obviously draw down 2 different reservoirs to give us the volume, and we drew both of them down 4 meters, which we were pretty happy that gave us, when we looked at the return periods, that gave us enough room for the amount of time that we were in the spillway, and fortunately we were correct on that. But yeah, that's the Lower Lliedi incident. So yeah, thank you for listening, and any questions?
Thanks, Sam. Thanks for doing that presentation. There aren't any questions within the chat at the moment, but would anybody... Oh, hang on, got the first one. Somebody has asked how far the line of the tunnel, how far was it from this location?
Yeah, hi Rich. So the tunnel crosses around about halfway up the spillway. So in terms of physical distance on site, probably around about 15 meters further upstream. But probably crosses at a higher level than what this is at that point.
Okay, thank you. Does anyone else have a question for Sam following his presentation? I think you've explained it very clearly there, Sam.
I've got lucky there. Yeah, I think if there is any as well, people come up with any or think of anything afterwards, then if you put it in the chat, I'll try and take a little bit of time to answer them as well.
Okay. No, thank you. If there's not any more questions on Sam's presentation, I will pass over to Matea for her presentation now.
Yes, hi, thank you. Thank you for giving me the... Well, I'm gonna need only a few minutes, to be honest. So hi, I'm Matea Clun. I'm the current chair of the ICOLD YPF. And I asked to have a short presentation today because I want to use this webinar to start announcing this year's election process and encourage people to send us nominations to be the member of the YPF board. Now, just to announce it, I will just give a little bit of a context of what we do so that you can see if you are a match for us or if you know a good candidate for us. So the ICOLD YPF is now active for 13 years. Our vision, our mission is to target professionals in the early careers and to provide opportunities for knowledge transfer, for networking, education, to organize or co-organize webinars like this one today. For example, if I remember correctly, also Sam was once a member of the YPF. Well, at that time it was called Young Engineers Board. So we are always getting very prosperous professionals in our board. So one of our missions is also to encourage professionals within the national committees to become active, to also form the forums, either professional or engineering forums within the national committees within the countries, and of course to collaborate with us to help us building the network and again providing opportunities. Since one of our goals is to we are the generations that will have to maintain, at least in Europe this is true, that will have to maintain the dams that were built in the past. So we are very lucky to get any possibilities for any knowledge transfers from the generations who are involved also in the construction of those dams. Basically about our activities, we try to be active online all year round. One of the examples are webinars like this. And we are very active and present during the ICOLD official events. For example, during the week of the annual meeting, we have our own young professionals meeting where also the elections happen. We have either our own workshops, lunch tables, sometimes even separate technical visit to dam sites. For example, during the conference in Marseille, there was a visit specially organized for the young professionals. The young professionals also have a reduced fee to attend the ICOLD events. And every year there is a YPF poster and paper award. So basically, if you're a young professional, if you have a poster or a presentation at an ICOLD event, your paper and your presentation and your poster are read, evaluated, and the best ones receive an award, which is basically you have a chance to attend the next year's event and you don't have to pay the fee. For now, there are over 100 ICOLD countries and 33 of them have already formed the young professionals groups. For example, UK has one, very active one. Here you can see on the map the distribution of the YPF groups. We are, of course, still encouraging formation of additional groups because we are, let's say, at 1/3 of our capacity. The goal is to majority of the countries to also have active young professionals within their national committees. And now if I move further about to the board members, it's 7 members who constitute the ICOLD YPF board. There is a chair and 6 members, and the term of office is typically 3 years. Now, every board member is elected, and every board member needs to receive an endorsement from the national committee that he or she represents. So basically, at the nomination, we require endorsement or nomination from the national committee, and we trust the choice of the national committee, and then a candidate has an opportunity to present themselves during the official YPF meeting. Now, we allow only 1 member of the board per ICOLD country, and our goal is to be diverse and inclusive. So we also aim to have a member of the board who is a member of the country who is next year organizing the ICOLD event. The idea is to have a direct link to the organizer so we can ensure to be in the program. And if I skip to the next slide, basically, as I said, we want to be inclusive and diverse. We don't have any special measures to ensure the inclusiveness and diversity, but it's since we have an election process where every young professional attending the YPF meeting can vote, for some reason this diversity and inclusion happens naturally. So we are keeping this format also for this year and also for the future. So about the call. This year we'll have 2 positions open, and the elections will take place in September in New Delhi in India during the official YPF meeting. Now, I don't know the exact date, but it's on Monday of the week of the conference. So very early in the schedule of the conference. So there are 2 positions open, and the term is from this year to 2027, so 3 years of a term. Now, we are already accepting, we are now starting to announce we are accepting the nominations. You can send them either to my email or to the email of the board of YPF. And as I said, you need an endorsement for the national committee, and we need a motivational letter from you where you present yourselves why you are a suitable candidate. You can also nominate somebody else, but still also another person needs an endorsement from the national committee. Then we accept your nominations, and of course we will communicate during the process via email, but then during the official YPF meeting in New Delhi, you have 1 minute of an elevator pitch time, and you are allowed to have 1 slide. So you have a time of 1 minute with 1 slide to present yourself to the people, to the young professionals present at the meeting. And after all the candidates present themselves, the election is happening. And of course, the 2 who have the largest number of votes are the next 2 members of the board. Another thing I have to note, we have an age limit. So members of the board and also young professionals within ICOLD are 40 years or younger. And since this is a 3 years term, so let's say it's not advisable to be 39 years old when you propose a nomination because it will only last for 1 year. The term is ending once you reach you aged out of our age gap. So it's advisable to find a candidate who is, let's say, young enough to have a whole term working within the board, because the first year or the first half of a year, you basically learn how to be included, and then it's basically the main time of the contribution. So if you don't have the chance to finish your term, you also don't have a chance to finish what you're working for. The obligations, of course, are to be involved in our activities, to help to organize them, and to attend the official event. So for example, at least once a year, you need to be able to travel to the ICOLD annual meeting, because we are needed there. We are participating in various workshops, and all the board members need to be there because we need the manpower to handle the things that are happening. Now for the conclusion, I would just like to mention that these webinars like this one today are recorded and are posted on the YouTube channel. So also today's webinars will be posted on the YouTube channel, and here we can see the list of the previous webinars that were recorded. We also have an active LinkedIn group. If you're not enlisted in one, you are encouraged to enroll in it. It's a group where we use it for informing about our activities, but also you can use it, you can be active in it, post questions if you find something interesting. It's basically used for a general exchange of information between the young professionals in ICOLD. And for the final slide, another webinar will be happening in 2 weeks. It's organized by the Chinese young professionals, and it will be about rock-filled concrete dams. So you're also invited to attend our next webinar. And with this, I'm concluding my presentation. Thank you.
Oh, thank you for that, Mattea. And so with that one, that will be the end of our session today. I'd just like to thank everyone for attending today. And the BDS does post about activities on LinkedIn as well. And then, as Mattea said, you've also got the ICOLD Young Professionals Forum group on there as well. And so with that, we will end this session. Thank you. Henry, could you please stop recording?